What's up? Welcome to Backend Stuff. I'm Jacob Blitzo, here to help you build tech for the future. Think about scalability, reliability, and cost. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. This is episode 6 in Elixir Basics. Today we are diving into recursion. Recursive functions are functions that call themselves, and due to immutability, loops in Elixir are written differently from imperative languages. For example, you might be used to something like this. So this is probably what you're familiar to seeing when you think of loops with programming. In a functional language like Elixir, mutating I by calling I++ is not possible though. Because of this, loops have to be implemented with recursion. Let's jump right in and start writing some code so I can show you what recursion actually looks like. Let's go ahead and pull up our terminal, command spacebar terminal. All right, let's cd to the desktop. And then let's go ahead and make a new project. Mix new recursion, we'll call it. And then let's go ahead and cd into our project. All right, let's open up, expand the lib directory, and let's open the recursion.ex file. And let's delete our hello world function because we don't need it. And like last time, let's go ahead and let's create a function that just returns our equipment list, Blork's equipment list. So let's go ahead and just do def get underscore equipment underscore list do, and then the end to close off the function. And we're just going to write out our equipment list, which is space helmet, comma, space suit, comma, snacks, comma, our grappling hook, comma, and last but not least, our probe. Okay, so that's just a function so we can easily set a variable in the shell again without having to write an array every time. Let's show you the simplest loop form of recursion. Like this would be replacing that for loop I drew on the screen. And a recursive function needs to have at least one base case and at least one recursive case. So let's write our base case for a loop. Let's just do def loop. And this will take an array and it will return nil. So if the array is empty, we are returning nil. This is our base case. So as we call our recursive function, our recursive case, the second that the list is empty, it knows to stop because we return nil instead of calling our function over and over again. So a base case returns a value without calling the function again. In this case, we're going to return nil. Now let's write the recursive case for loop. And that will look like def loop opening parentheses, and let's pass in a list with a head and a tail. And if you recall last time, we touched on head and tail in our lists episode. And then we'll go ahead and do, and now here is where you would manipulate or do something with the head as you call this function over and over, right? Just for demonstration purposes, I'm going to just do an IO puts, and we're going to just print out the value of head in the terminal. And then we're going to call loop again. And this is the recursive part. So we're going to call loop and pass in the tail. So a recursive case calls the function again, modifying the input so that it will at some point match the base case. So if you recall, the head is the first element in the list and the tail is a list of everything else. So if we just output the head and then send the tail back in, it's going to be the list minus the first element, right? So every time we pass it back in, it'll be minus the first argument. And that means eventually it'll be an empty list and return nil. So we will not just continually call our recursive function because it will hit nil and it will stop the loop. In this case, we only pass the tail back into the function. So at some point, the tail will be an empty list, which will call our base case and return nil, ending the recursive loop. Let's go ahead and pull up our terminal and go into the Elixir shell. So IEX space dash capital S mix, and that compiles our project for us. And then we can go ahead and let's set our variable list right away. So list equals recursive.get equipment list. And there we go. We set our variable to the list we made. And now let's pass that list into our recursive function, our recursive loop, which should just print out each element every time it goes through. So we should have a list of space helmet, space suit, snack, and so on. So recursion.loop, let's pass in our list and hit enter. And there you go. So each iteration, it printed out the head of the array. And then when the list was empty, it returned nil and it stopped the recursive process. Pretty cool, right? I personally think recursion is way cooler than a for loop. Let's create a function already given to us with the kernel module, just so you kind of understand how it works. Because anything in the enum module or the list module that is iterating or mapping through variables is actually doing recursion on the back end. So let's do length, the kernel function length, where if you recall, if we do length like this and pass in list, it would return the count and how many items are in the list. So instead of using this function, let's make our own so you understand how it's actually working behind the scenes. We want to count the items in a list. So let's start with our base case, which is going to be def equipment underscore count. And then when our list is empty, we want to just return 0. For the recursive case, let's go ahead and do def equipment count. And now we're going to pass in an array with head and a tail like before. All right. And then close parentheses, comma, do colon. And now we just want to do, so every time there's a value, so every time we have a head, we want to add 1. And then we want to call the recursive case again. So we want to call equipment count and pass in the tail. As long as our array is not empty, we're going to do 1 plus 1 plus 1 plus 1. So we're essentially calling equipment count over and over as long as the tail has values in it. And then the second the tail doesn't have values in it, we add 1 plus 0, and we don't call the recursive case again. The very first time we pass in the list, the head is going to be space helmet. So we're saying 1 plus, and then we're calling the recursive function again. And as long as like we have space suit, it's going to be 1 plus again. And then we're calling the recursive function again, and it's going to be 1 plus. And then let's pretend, so we call that function, let's pretend it is an empty list now, and our base case is going to return 0. So then we're done, and we would get, like in this case, what I drew up, we would get 3 back because it's 1 plus 1 plus 1 plus 0, which is 3. And then we would have 3 returned to us. So that's pretty cool. Recursion can be a little hard to wrap your head around, but when you get it, when you see like the power of it, like now you're seeing how the length function works that we just can easily use at any time. And let's go ahead and pull up our terminal and let's recompile. And now if we call our function that we just created, our recursion dot equipment count, and we pass our list in, we should get 1, 2, 3, 4, 5 items back, or a count of 5. And there we go. We got 5 back. So our recursive function works. And if you can see that my IDE is yelling at me because the variable head is unused. So when you have a function and you're not using one of the variables, with Elixir, you can just put an underscore and then the name, and it knows it's an unused variable. Now we won't get yelled at, and people understand that there's a variable there. We don't need it for our operation. And that's all you have to do. That is how the length function works behind the scenes. Let's do something a little cooler. Let's maybe format our list. Let's say we want each item to be just more consistent. Right now we have, space helmet, space suit. We got spaces in there. We have lowercase, uppercase. We could have a ton of different things, right? Let's write a function called format equipment list. And let's just make sure everything is lowercase. And then let's also replace spaces with underscores. But we're going to do this with a recursive function. So let's make our base case first. So that would be def format equipment list. And then when the array is empty, we want to return an empty array. And now for our recursive case, let's think about how we're going to do that. We know we're going to need an array with the head and tail. So let's do format equipment list, and let's pass in our head and tail array. Okay. And then let's do a do and let the end go there. Okay. So we've already done string manipulation in the past, so we should be pretty familiar with the string module. And since the head is the current item that we are formatting, let's go ahead and do head, and then we can use the pipe operator, and we want a lowercase. So let's call that string module and downcase. And that's all we have to do. Now everything will be lowercase, and we want to replace spaces with underscores. So let's do the pipe operator again and do string module replace. And now you put in the pattern you're looking for and what you want to replace that pattern with. So we're going to just do a space between two double quotes, and we want to replace that space with an underscore between two double quotes. So we have the head formatted. Now how do we return the head? We want to return a list. Let's go ahead, and if you remember, prepending lists is the pattern we want to follow versus appending. So let's put our head inside of square brackets. So it is in a list, and I'm just going to bring the pipe operators up next to it. It works the same exact way. So we have our head value, and now we want to prepend with the cons operator, the pipe key. So we want to prepend the list with all the next recursive actions that happen. So we're just prepending our format equipment list, and we just want to pass in our tail here and then space and do a close square bracket. All right, so what is happening with this? Do you guys understand, or should we walk through this? I think we should probably walk through this a little bit. So we are prepending our formatted head value to our function that returns a formatted head value. So with the recursion, let's go ahead and just, here, let me draw on the screen again. So we're getting a list back, right, every time. And the very first head value is space helmet. And space helmet is getting all lowercase, and spaces are removed. I can spell almost. Okay. And then we're basically just prepending this to another function call, which will be spacesuit. I'm running out of room here. And then we're prepending that. I'll just come down here. We're prepending that, and then we'll get, snacks back, all lowercase, no spaces. And we just keep prepending it until we hit an empty list, right? And then we're getting returned with an empty list from our base case. So eventually we're just appending all these strings together into a list, or we're prepending, I'm sorry. And then once we hit our base case, we don't call the function again, and we just prepend our existing list to an empty list so it doesn't change anything. And we just get our whole list back of values. So it's just a bunch of strings now with our formation or our formatting done, just like that. Okay. So if we go to our terminal, let's recompile and let's do our recursion dot format equipment list, and we want to pass our list in. And now, as you can see up here, we have, spaces, capital letters. It should return all lowercase, no spaces, and underscores, right? Hit enter. And there we go. So it, formatted one value at a time and then called our recursive function and went all the way down, all the way through. And then when the tail was an empty array, we call our base function, and it then ends the recursive pattern. So a recursive function can have many base cases and or many recursive cases. So let's take a look at what that would look like. Let's write a recursive function that counts the occurrences of a specific value we pass in. So I want to know how many times snacks is in our equipment list. It should be 1, right? But how would we write that? So let's start with our base case, and that is def, occurrence underscore count, and let's pass in an empty array, or when the array is empty, this case will be called, and the value that we're looking for, comma, do, and when we hit this, obviously there is no value match, so we're going to return a 0. That's our base case. So when the array is empty, because there's no value that would match at that point, we return a 0. Because it's just counting. We're just counting 1 plus 1 plus 1 plus 1 plus 1. You get it. Okay, so let's write our recursive case now. So def occurrence underscore count. And we need our array with our head and tail, right? We're going to do something a little different though. We're going to put value here, cons operator, tail, closing square brackets, comma, and value again. And then we're going to do a do colon 1 plus occurrence count. And then we're going to pass our tail in and our value. So what's happening here is every time our head value equals the value we're looking for, we're going to add 1 to it. So it's kind of working like our equipment count, but we're passing in a value and we're matching head to it. So when head equals value, we add 1 to it. Okay, so what happens when it doesn't match? We have a value as our head and as the argument. We are passing in to find the occurrences of this value. So if our head matches our value, we'll add 1 and call our recursive function again. Okay, so what happens if it doesn't match our value? We need our second recursive case for this. So let's write that. Let's do a def occurrence count. We need to pass in our head and tail. So head, tail, and then we need to pass in our value that we're looking for. So if this doesn't match, we just want to call our occurrence count and pass our tail and value in. So this time we don't add anything, right? So we're just calling the function again because we have more list elements to iterate through, right? So if value doesn't match the head, this would be called. And we're not using head, so I'm going to put an underscore there. And we're not using value, so put an underscore in front of it and save it, and the IDE will stop yelling at us for not using variables. So if the value doesn't match the head, we just call a recursive function again, and we don't add 1. So let's go ahead and pull up our terminal and let's do a recompile. And let's go ahead and let's see. I want to actually set our list to equal our formatted list so everything is consistent for us. So let's go ahead and let's see. We want to format our equipment, pass in list, and now everything is formatted the same way. Let's try our occurrence count function that we just wrote. So recursion dot occurrence count. Let's pass in our list, and what value do we want to look for? Let's look for snack, okay? And then hit enter, and it returns 1 to us. Cool. Now let's just do something that isn't there, and it should be 0. Let's go back into our code, and let's maybe do another snack up here, okay? Because I just want to show you that it will return a 2 for us. So we need to do list equals, oh my gosh, recursion dot get equipment list. All right, I'm not going to format it this time. Oh, I forgot to save it or recompile. I forgot to recompile. All right, let's set our list to our new list, and now we have 2 snacks, right? We're not going to format it this time. We don't really have to. Let's go ahead and pull up our occurrence count where we pass in snacks. Case does matter, case sensitivity with this. So I'm just going to capitalize that snacks and hit enter. Oh, it needs to be snack. All right, hit enter. And now we have 2 occurrences of snack. So that's really freaking cool, right? And like I said, so we can have multiple recursive cases. We can also have multiple base cases. What if we want to do something special for a certain value that we're passing in? Like for instance, if someone is looking for a snack and we don't want our recursive function called for this, we could do another base case and do def occurrence count. And then let's pass in underscore head, cons operator, underscore tail, and then finish this closing bracket. And the only reason I have underscores in there is because I don't plan to use the header tail. And then when value is snacks with a capital, or snack with a capital S, all right, and then close parentheses, comma, do, I want to just return 400 here just to show you. So now when we call occurrence count, and if our value is snack, it's not going to call our recursive case again. It's going to just return 400. So let's go back to our terminal and hit recompile. And now let's go ahead and do our occurrence count, pass in snack. And look at that. That's pretty cool. We get 400. And if I were to go back into our occurrence count and type in, I don't know, spacesuit, we're going to get the recursion function, the recursive case called, and we get a count of 1. I hope you're seeing the power that you're capable of with recursion right now. It's pretty freaking cool. So there can be some problems with recursion. If you aren't careful and you don't properly return results you expect, you could get an infinite execution loop. This can be a problem because each time a function is called, a reference is stored in memory where the VM should return the result. So if your recursive function is called indefinitely, you could run out of memory, causing the VM to crash. This is called a Stack Overflow error. And one thing with the Erlang VM, which is what Elixir runs on, is it's optimized for recursion and reliability. So it could be a long time before you actually catch an infinite recursion error. This is one reason writing tests can be so important, because if your tests fail, you know you're not getting values returned or something is not working the way you expect it. So a few things that can cause an infinite recursion are no base case, or not defining your base case as the first clause, or not modifying an argument properly so your base case is never called. Just to show you an example of what would happen, if we modified our base case for equipment count, and instead of returning a 0 here, Let's call equipment count again and pass in an empty list. And let's save it and go back into our terminal, recompile, and now let's call that function. So recursion.equipment count, and then pass in our list and hit enter. And it's pretty much just locked up on us. So we got stuck in an infinite recursion loop. Nothing's being returned, so we can't even use the shell anymore. We don't ever want that. That is not good, but we know that something's broken now, right? So we're gonna have to Control C twice to get out of this because we got stuck in an infinite loop and never got returned a value. Your challenge, as always, is write documentation for these functions, write tests for them as well. And now you kind of saw a reason for writing tests, right? And then also write a recursive function that returns a list of values that contains part of the value. So for instance, if I pass in space, whether it's capital or lowercase, I want it to return a list of every equipment string with space in it. So I want space to return a list of space helmet and space suit in it. So I don't want it to match characters exactly. I want it, if it contains the search or the string you're looking for, I want it returned in that list. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. See you next time, guys.